My name is Nur Alia Afika binti Azman, metric number 2023239052. So today I'm going to present task 1. In the group list, our group is number 8. So the binary number for the 4-bit binary is 1000. Meanwhile, for the 5-bit binary is 01000. So for the task 1, we need to build a 4-bit circuit and a circuit according to the page 15 in the lab manual. For the first circuit, I chose the NAND gate with 2 inputs and OR gate with 3 inputs, 4 of toggles as an input and a logic probe as output. Firstly, we connect the first 2 toggles to the NAND gate. The output of NAND gate we connect to the OR gate as an input. As you can see, the output from NAND gate is 1. So we continue connecting the rest of the input. The last 2 toggles we connect to the OR gate. And as you can see, the number of logic probe is 1, which means it is in high state even when all inputs are low. It's because NAND gate behavior. NAND gate will only produce a low output when all inputs are high. However, since our group binary number is 1000, the input of first toggle is set to 1. NAND gate receive 1 as an output, hence the output of logic probe is 1. Moving on to the next circuit, so the task instructed us to construct a circuit at lab manual on page 15. According to the page 15, we need an AND gate with 3 inputs and an OR gate with 3 inputs, 5 of toggles as an input and logic probe as output. Firstly, we connect the first 3 toggle to the AND gate. Meanwhile, the output of AND gate we connect to the OR gate as an input. We also connect the rest of toggles to the OR gate. The final output will be the result to output logic probe.
Hi, in this video, we will demonstrate task 2. The objective is to physically implement a single AND logic gate using the 74HC32 IC and observe its output. First, we connect the 5V or 9V power supply to the breadboard rails. The positive terminal is connected to the positive rails and the negative terminal is connected to the negative rails. Next, place the 74HC32 IC across the middle notch of the breadboard. This ensures that each pin is properly separated and connected correctly. Then connect pin 14 of the IC to the positive voltage. Connect pin 7 to the negative terminal or ground. This step supplies power to the AND gate IC. After that, connect pin 3, which is the output pin, to a 1 kilo ohm resistor. From the resistor, connect to the long leg anode of the LED. Finally, connect the short leg cathode of the LED to the ground. Next, connect 2 slide switch to input pins. One switch to pin 1 and another switch to pin 2. This switch acts as the 2 input of the AND gate. Let's test the circuit. When both inputs are high, the LED lights up, indicating a correct AND gate operation. When one switch is off, the LED lights off. This lab simulation successfully demonstrates the operation of an AND logic gate using the 74HC32 IC. The output behaves according to AND gate truth table.
The simulation represents a circuit that combines AND gate and OR gate to control LED based on different switch inputs. The circuit is built on a breadboard. An LED is used as the output indicator connected with a 1 kilo ohm resistor to protect it from too much current. Two logic ICs are used, 74HC08 for the AND gate and 74HC32 for the OR gate. Both ICs are placed with the notch facing up to ensure correct pin placement. There are three switches labeled as A, B, and C. When any switch is turned on, it sends a signal to the circuit. The power supply connects to the breadboard to provide power to the ICs. The wiring is set up so that switch A and B are connected to the input of the AND gate. The output from the AND gate is connected to one input of the OR gate. Switch C is connected directly to the other input of the OR gate. The output from the OR gate goes through the resistor to LED. When the power is on, the LED lights up when both A and B are on together, or when C is on. If none of these switches are on, or only A or B is on alone, the LED stays off. The simulation tests all possible combinations of three switches are shown in the truth table. The LED lights up only when both A and B are on together or whenever C is on. This confirms that the combination of AND gate and OR gate works correctly to process the inputs and the control LED outputs.
This simulation demonstrates the method of displaying the number 8 using common cathode 7-segment display. The circuit is powered by a 9-volt battery. The positive terminal is connected to the positive rail of the breadboard, while the negative terminal is linked to the ground rail. A resistor is included to limit the current and protect the 7-segment display from potential damage. The 7-segment display is made up of 7 LED labeled A to G. In a common cathode configuration, all the cathodes within the display are connected together and grounded. Each segment is activated by applying voltage to its respective pin. To display the number 8, segment A, B, C, D, E, F, G are powered. When these segments are turned on together, they form the shape of the number 8 on the display. In this circuit, wires are connected from the positive rail to each of these segment pins, causing them to light up.